Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, in the last session we have covered the part 1 with the empirical formula. Now let's start with the part 2 with the molecular formula. So in this session we are going to cover with the concept and definition of molecular formula and the calculation of molecular formula, also with the calculation of percentage composition of compound. Let's start it one by one. So friends, what is molecular formula? We learned empirical formula in the last session. What is it? It is nothing but the simplest ratio, or you can also say the lowest ratio of the different types of atom present in one molecule of compound. Basically, it does not show the actual number of various atoms present in the molecule of the compound. In the last session, I gave you an example of hydrogen peroxide, where the empirical formula of the hydrogen peroxide is this. Do you think this is the actual hydrogen peroxide formula? No. This is the actual one. This formula is also called molecular formula. So friends, now you can differentiate what is a molecular formula. So let's define molecular formula, that it is the formula which shows the actual number of different types of atom present in one molecule of compound. I hope you are following the concept. This is the basic difference. It is the actual number. So if I take the example of hydrogen peroxide, so this is the actual number of hydrogen peroxide, where there's two hydrogen and two oxygen combining to form hydrogen peroxide. In the last session I gave you a very simple example of tea, right? If for one head it was like we had A B C D, it was like 8 and 4, somewhere 1 and 2, something like that. So if I want to prepare for 4 people, we just have to multiply this by 4, right? So we can get here the total number of composition. Or you can say the ratio of the ingredients of the tea. Similarly, here is the molecular formula, which is just the multiple of empirical formula. You can also write here like this. molecular formula can either be equal to the empirical formula, or it can be also simple multiple of the empirical formula. For example, this you can write here like this: empirical formula bracket closed by n, where n is the simple whole number like 1, 2, 3, 4, right? So for example, empirical formula of hydrogen peroxide is HO and its molecular formula is H2O2. So in this case, the number of the simple whole number will be n. That is n for this, n is equal to 2. But in many cases, it has been seen that the empirical formula is just equal to the molecular formula. In many special cases, is also equal to the molecular formula. For example, you can see water, you can see carbon dioxide, you can also see ammonia and methane. These are basically the compounds where the empirical formula is just equal to the molecular formula. And friends, if you want to find the number of n, how do you do this? You just have to do some basic mathematics. We just have molecular mass of compound upon empirical formula mass of the compound. So let me take an example of hydrogen peroxide only. How can I get n equal to 2? As let me write empirical formula as EF of HO, hydrogen peroxide. So the mass of empirical formula mass of the compound will be 17, that is addition 1 plus 16 is 17, and the molecular formula of the compound is 32 plus 2, it is 34, right? So how can I get n? Just putting 34 by 17, we get n equal to 2. So empirical formula is like this. You can write like this also. So this converts into molecular formula. So let me find out now how to calculate the molecular formula, which is also a very easy task. When you have already learned empirical formula, you can also find the molecular formula of a compound. Let me clear out how. From here also we have many steps. So in order to calculate molecular formula of compound, first of all, we should find out its empirical formula, which we have learned in the first part. So to calculate the molecular formula, we should know the molecular mass of the compound. Let's write down steps for molecular formula. First, we should know or calculate empirical formula. Second, we should calculate or know the molecular formula, that is the molecular mass. So in this second step, what we have to do, we have to just divide molecular mass upon empirical formula mass to get N. So after getting N, it's very simple to put the values in the main expression, which is molecular formula equal to empirical formula by N. So let's understand by a simple example. Friends, I'll give you the example carbon and hydrogen again, which were a gaseous compound containing carbon with 75%. So hydrogen, if we imagine it's 100%, then it will be 25% by mass, both by mass. And the molecular mass of the compound is 16, right? So let's find out the molecular formula now. So first of all, we have to find out empirical formula. First step. So empirical formula for this compound is CH4, which we have calculated in the first part of empirical formula. You can also go through the video of empirical formula, first part. So this is the empirical formula, right? So now second step, we have to know about the empirical formula mass, which is mass of carbon plus mass of hydrogen, which is 12 plus 4 equal to 16. Now just put the values in the expression from where we can get the value of N in the expression molecular mass, which is given in the question, and the empirical mass, that is the empirical formula mass, which comes out to be 16 by y equal to 1. So the molecular formula is equal to the empirical formula by N. Just put the values of N. We can get the value of molecular formula. So CH4 is the actual formula of composition of the carbon and hydrogen. So this is the molecular formula. Here you can see molecular formula and empirical are just equal to the each other as the number of n, that is the n is equal to 1. So friends, by this you can get the calculation of molecular formula. So now we can also understand about the calculation of percentage composition of the compound. This particular portion is very important for the competitive exams and future students who want to pursue their career in chemistry and the sciences. So how do we calculate the percentage composition of a compound? Let's understand by the rough work. First of all, what is the percentage composition of the compound? What is it represents? The percentage composition of compound is nothing but representation of the mass, or you can also call it weight of element, that is each element which is in the compound, per 100 grams of the compound, right? For example, if I want to calculate the percentage composition of methane, that is CH4, which is 75% carbon and 25% of hydrogen element. So the percentage composition of the compound can be calculated from the formula of the compound. So in fact, in other words, to calculate the percentage composition of a compound, we should know the formula of the compound as well as the atomic mass of all the elements which occurs in the formula of the compound. Let's write down the important note. First of all, we should know the formula of the compound. We should also know the atomic mass of each element present in the compound, right? So there must be a proper expression to find the percentage. Yes, we use this relation percentage of element is equal to the mass of that element which is in the compound upon the molecular mass of the compound into 100. So let us calculate the percentage composition of a compound which is called methane. As we have just derived the molecular formula methane, which is CH4. So let's calculate for this compound. So the formula of methane is CH4, methane containing 1 carbon and 4 hydrogen atom with 1 atomic mass of 12 and 4. 4 comes by 1 into 4 of hydrogen. This is the carbon. So friends, what is the molecular formula of methane? Molecular mass of CH4 is 16 by adding 12 plus 4. So the percentage of carbon is mass of carbon in methane molecular mass of methane, which is into 100, which is 12 upon 16 into 100, comes out to be 75%. Similarly, you can calculate for hydrogen. After calculating, it will be coming out 25%. So the percentage composition of methane is 75% of carbon and 25% of hydrogen. I hope this session is more clear now, as we have already understood about the empirical formula, the steps to find the empirical formula. So this part 2 session is more easy for you if you have thoroughly seen the part 1 section. So friends, here I conclude section by points. Let me take in a marker first. So what is the molecular mass? It is the actual number of masses of element present in the compound. What is the molecular formula? It is the multiple of empirical formula. Sometimes it is equal to the empirical formula also, where n is whole number. How do we calculate the percentage of element in a compound? By the mass of that element in a compound upon the molecular mass of compound, right? So friends, you just need to understand these few points, that the lowest whole number ratio of an element in a compound, which is an empirical formula. The molecular formula is the actual ratio of the element in the compound. These two, empirical and molecular formula, can sometimes be same, as for example CH2 is the empirical formula, C2H4 is the molecular formula, C3H6 is the molecular formula, but H2O2, which is a water, can be both. That is, it is also an empirical formula, it is also a molecular formula. So friends, from this I end up with the session of both the parts. Now it's your turn to do an activity. I have just given you 5 very simple questions which you can easily write down. Thank you.